This will be a short review of the importance of units and the so-called sig figs. I'm assuming most people know something about sig figs, so this is just a short review. First is converting units. I assume everyone knows how to do the basic fence posting. However, one thing I want to make sure everyone is aware of is if you have a TI graphing calculator, check the apps button on it, and you should find, if it's a newer one, an application called SciTools. That does in fact allow you to convert units. Many of them are the kinds of conversions we'll be using. It also does have some very useful constants on it. It does a bunch of other things, but what I want you to do is find that on your calculator and see if you can convert 135 feet to meters. After you've done that, take a look, open a web browser on your computer, and take a look at the unit converter on Google. You can access that either by just searching unit converter, or if you want to specifically convert, for an example, 135 feet to meters, you enter 135 in the unit feet, then dash dash angle bracket, and then the unit you want to convert it to, meters, hit enter, and then you will also get the unit converter, but it will specifically convert the 135 feet to meters. So again, pause the video and try that and see if that works. At the end of this, I want you to take a quick survey to let me know whether or not you're able to get those to work. One important thing about units is that almost all the numbers that we'll be using in this course will have units. At no point should we have naked numbers floating around. It's embarrassing for them and it's embarrassing for you, so there should be no naked numbers, which is to say all numbers should have units. There are some exceptions. Exponents, for an example, do not have units. Sometimes we'll deal with just counts of things. That doesn't have a unit. Ratios of numbers often will not have units. But beyond that, most numbers should have units. So when you write something down, you should always pause and ask, oh, wait a minute, what units should I use? However, not only should units be dressed, they should be dressed appropriately. So let's consider approximately 12,800 seconds. That's not really an appropriate unit for that particular number. Because if I told you, meet me at Starbucks in 12,834.6 seconds, you would have no idea what that means. You would probably have to mentally convert that. So I want you to think about what would you convert that to so the number has some meaning, or if you will, it is properly attired. Think about that for a few minutes. You might want to pause the video again. When you restart it, you should realize probably want to convert that large a time into hours. So that is actually about 3.5 hours. So hours would be the appropriate attire for that number. Now, sig figs. I'm assuming most people have the general rules for sig figs. There's a link on Canvas that will give a quick review of sig figs. I'm not going to do that here. One thing I do want you to remember, what are the rules for zeros being significant? General guide I'm going to use for this course is just cite everything with 3 sig figs, particularly homework problems, test questions, just use 3 sig figs. It's very unlikely we will ever be calculating anything that will require more than 3 sig figs. And when that's true, that should be obvious because most of the data in the problem will have many, many digits, and that might be part of the point of the problem. Generally speaking, less than 3 is not needed, so that's a good general rule. Recall that when we did stats, we did see what is the technically correct way to cite the sig figs for an experimental value. Namely, what you do is you repeat the experiment over and over, you calculate the standard error. The standard error is cited to 2 sig figs. You then take the least significant digit of the standard error, and that is the last digit that you cite in the mean value. So for an example, if we cite a value of 1.234 and our standard error is 0.012, the third decimal place is the last significant digit in the standard error. So therefore, you cite 3 decimal places for the mean value. If it's 45.2 plus or minus 1.2, the first decimal place is the last significant digit in the standard error. It should be the last significant digit in the mean value. Now, if we have something like 423 million plus or minus 12 million, that often should be expressed in scientific notation, and one convenient shorthand is to put the standard error just in parentheses next to the value. So 4.23 with 12 in parentheses times 10 to the 8th means 4.23 times 10 to the 8th plus or minus 1.2 times 10 to the 7th. Now, let's consider some examples. Here I've got a rectangle 12 inches by 18 inches, and I want you to find the area of that, but I want the area in square centimeters. So pause the video, do that calculation, and then restart the video. Okay, when you restart, hopefully you'll do the following. We'll take the first number, the 12 inches, and convert that into centimeters. Also, we'll convert the 18 inches into centimeters as well. Plugging all of that into a calculator, we get 1,393.5456 square centimeters. If you found that to be the answer, okay, you can do math, but we just reviewed sig figs, and that is not to the correct sig figs. Both of our dimensions only have 2 sig figs. We cannot say that we know the area of this down to the tiny fraction of a square centimeter. Instead, we really only know it to plus or minus 2 sig figs, so we should cite that as approximately 1,400 square centimeters. I would say it would be okay to keep the third digit there and say 1,390. That would be okay. But if you went all the way out to the fourth decimal place, the answer would be no. That's wrong. A second example. Convert the speed of 45 miles per hour to meters per second. This is something we often will be doing because we usually think of speeds in miles per hour, but we will be using metric units, in particular meters per second, when we do a lot of our calculations. So again, pause the video and convert 45 miles per hour to meters per second. Okay, the conversion is 45 miles per hour. Convert the miles to kilometers, and here's the conversion factor. And we convert hours to seconds. Remember, there are not 60, but 3,600 seconds in an hour. Again, plug all of that in your calculator, and you get this number. However, again, we do not know the speed out to this many decimal places. There's only 2 digits in 45. There should be only 2 digits when you cite the speed in meters per second. Converting a value from one unit to another does not make it any more precise. So the correct speed should be 20 meters per second. And that's our brief review of significant figures and units.